Lesson 56, identifying, writing, and graphing direct variation. We have basically two types of variation. That doesn't look, I believe I got about a -10 on spelling right there. variation. We don't need that N right there. Okay, we have essentially two types of variation, direct and inverse. Sometimes inverse variation is called indirect variation. And I like to have a mnemonic, which is a learning aid, to help me remember things. So I use the mnemonic for this to help me remember what direct and inverse variation are. I use for direct variation, since direct starts with DI, direct variation implies division. Okay, so here would be at y over x, which is division, is showing division, and that's equal to a constant or some number. Our textbook shows this as y equal k times x, where k is a constant. There's no obvious division here, but if we were to solve this equation for k, then k would be equal to y over x. So direct variation implies division. So if direct variation would imply division, what would inverse variation imply? We'll cover that in a future lesson. Okay, so does this represent direct or inverse variation? Well, let's see. I don't see any division here, but we could manipulate this formula a little bit. We could subtract 8x from both sides, and we would have y is equal to minus 8x. And then we could divide both sides by x, and we would have y over x is equal to minus 8. Minus 8 is a constant, and here is our what? Our division. So this is direct variation. Okay, let's look at this one. Okay, so here's some division. Is it direct variation? Well, let's see if we can't get it in the form y over x. So we would need to multiply both sides by 10 to get this 10 out from under the denominator. So we would have, those would cancel, so we'd have y is equal to x or 10x. And then we divide both sides by x, so we would get 10 is equal to y over x. That didn't look like direct variation initially here, but after we worked it down to where we had y over x, it was in fact equal to a constant. So this would be an example of direct variation. Okay, let's look at one more. We've got x times y is equal to equal to 6. Well, here's x and y on the same side of the equation, and what's the arithmetic operation indicated here? Well, it's multiplication, not division, so this is not direct variation. I spelled variation correctly there. I hope you noticed. Okay. All right. Do the following ordered pairs represent direct variation? Okay, so ordered pairs. Well, that's like x and y, right? Our x value and our y value. And what was our indicator for direct variation? If we had y over x was equal to some constant, right? Okay, so let's just put y over x minus 14 over 2. That's equal to minus 7. Let's do this one. Minus 35 over 5 equals minus 7. 21 over minus 3 equals minus 7. So all of these are equal to the same constant. So these points represent direct variation. Do the following ordered pairs represent direct variation? Well, let's remember y over x is equal to some constant. Okay, y here is 4 divided by 2 equals 2. 5 divided by 3 equals not 2. Okay, do we need to go any farther? Well, we could, but 7 divided by 5 is also not 2, so it's not direct variation. Okay, one other topic here is write an equation given the point 6, 24. Okay, 6, 24. Here's our x, here's our y. So we put y over x, 24 over 6 is equal to k. So k is equal to 4 in this case. So we could come back and put 4 in here for k. And so our equation would be y over x is equal to 4. If we wanted to cross multiply or multiply both sides of the equation by x, we could do that. The x's would cancel here, and we would have y is equal to 4x, which would be an example of direct variation. Lesson 56 homework, 1 through 12, 14 through 17, 20, and 30. And please email the answers to numbers 8 and 9.